This is Chapter 5.1, Exercise 9 through 16. This section 5.1 has to do with using trigonometric identities, sometimes to solve equations, sometimes simplify expressions. In this case, we're say find the value of each expression using the given information. So we have find the secant theta and cosine theta if tangent theta equals -5 and cosine theta is greater than 0. What really helps is to figure out where we are to find the signs of our answer, because when we're solving an equation by using the square root method, which we're going to have to do here, we need to know we're going to have plus or minus as an answer. So drawing a linear unit circle with an x-axis and a y-axis, we're going to examine cosine theta greater than 0. Well, cosine theta is going to be greater than 0 where? Let's see, where? That's going to be quadrants 1 and quadrant 4. Let's say quadrant 1 and 4. There we go. And so that's what that's going to look like. And also we have tangent theta is -5. Well, tangent theta is going to be less than 0, which -5 is. Where? Well, that's going to be in quadrants 2 and quadrant 4. Quadrants 2 and 4. Quadrants 2 and 4. And so between these two sets, the thing we have in common here is quadrant 4. So that'll just help us when we get our answers. Now, let's look at what we're going to try to do here. We're given tangent. We're asked to find secant. Well, what happens, there's a Pythagorean identity that goes like this. Tangent squared theta plus 1 is equal to secant squared theta. And in case you didn't know, let's review what we say secant squared theta. This notation, what do we really mean? What we really mean is we're taking that value secant theta and squaring the whole thing. So the notation is to have a little exponent 2 between the secant and the theta, but really it's the whole thing squared. So that's going to be necessary for us to figure out what's going on. So let's go ahead and plug into our formula here, our trigonometric identity, Pythagorean identity. In the place of tangent theta, we place -5, and we know that's going to be squared, plus 1 is equal to secant squared theta. Now, -5 squared is going to be 25 plus 1, that's going to be 26. So secant squared theta is going to be equal to 26. And taking the square root of both sides, secant theta is going to be equal to square root of 26. Now, is this a correct answer? Well, yeah, it is, except not complete, because we're solving using square root methods. We're going to have a plus or minus. But in this case, we should know that secant theta is 1 over cosine theta. And remember, we're given that cosine theta is greater than 0. So secant theta also has to be greater than 0. So let's go ahead and write this out. We'll say, therefore, secant theta equals square root of 26. Now, cosine theta equals 1 over secant theta, which in this case is going to be equal to 1 over square root of 26. And square root of 26, what we can do to get this rationalized is we take 1 over square root of 26 And rationalize means to get our radical expression out of the denominator. So we can multiply by 26, square root of 26 over square root of 26, and we get, multiplying across the numerator, 1 times square root of 26 is going to be square root of 26. And multiplying our denominator across is square root of 26 times square root of 26 is 26. So the cosine theta is going to be equal to unrationalized 1 over square root of 26 and rationalize square root of 26 over square root of 26 over 26. And the book has both ways here, and so we're going to box in both of our answers here is correct. And for secant, we just have square root of 26. Okay, next other problem, 11. Okay, we're trying to find tangent theta and sine theta, and we're given the secant theta is 4 and sine theta is greater than 0. So going back to our little unit circle sketch up here in the upper right, okay, we have this, x, y. Well, sine theta is greater than 0, where? Well, it's going to be here above the x-axis. So in quadrants 1, in quadrant 2, sine theta is greater than 0. So we'll say quadrant 1, comma 2. And then we have secant theta. Well, cosine theta equals 1 over secant theta. So if secant theta is greater than 0, cosine theta is also greater than 0, which means we have quadrants 1 and 4. Quadrant 1, comma 4. So here's quadrant 4 in the lower right. And the thing we have in common between these two sets here is quadrant 1. So all trigonometric ratios are positive in quadrant 1. Well, in this case, we could use the one we did in problem 9, but what I'm going to try to do here, I think it might be a shade easier if we change this secant to cosine, and then we might explain a little bit later. But I'll say cosine theta equals 1 over secant theta, which equals 1 over 4. And then if we use our trigonometric identity, Pythagorean identity, sine squared theta plus cosine squared theta is equal to 1. Well, we know the cosine squared theta already. So we can just take sine squared theta plus cosine squared, which is 1/4. Now, one check you have is cosine theta is going to be between 0 and 1. So if you end up with a cosine or sine greater than 1, you know you're in trouble. Well, you have sine squared theta, and what is 1/4 squared? Well, that's going to be 1/16. And 1, how many sixteenths do we have in 1? We have 16 sixteenths. And if we subtract 1/16 from both sides of this equation, we're going to have sine squared theta is equal to 15 sixteenths. And taking the square root of both sides, sine theta, it's going to be equal to, we have square root of 15 over square root of 16, which is 4. And we have to worry about plus or minus, don't we? Well, we know sine is greater than 0, so this will be our answer here. Okay, now we just need to find out what our tangent is. Well, tangent theta equals sine theta over cosine theta, which in this case, tangent theta and our sine theta we figured out was square root of 15 over 4, and our cosine theta is 1/4. And what's the same as dividing by 1/4? What's the multiplying by 4 over 1? And we cancel 4 over 4, so our tangent theta is equal to square root of 15. So that's our answer for problem number 11. Problem 13. We're trying to find cosine theta and tangent theta, and we're given that cosecant theta is 8/3 and tangent theta is greater than 0. Again, back to our unit circle. Well, here's our unit circle. We have xy. We have cosecant theta. That's going to be related to sine, so sine theta is going to be reciprocal of cosecant theta, which is going to be 3 over 8. And therefore, we have, that's going to be positive. So sine theta is greater than 0 where? Quadrants 1 and 2. And then we have tangent theta is greater than 0. Well, tangent theta is greater than 0 where? Well, quadrants 1 and 3. Because sine divided by cosine, quadrant 3 is going to be positive. So between these two, what do these two have in common? Well, definitely we're talking about quadrant 1. So all the trigonometric ratios are going to be positive here. So we have now the sine theta. We can find, I think, cosine theta pretty easily, I believe. So if we take cosine squared theta plus sine squared theta, that's going to be equal to 1. And we are trying to find cosine theta, cosine squared theta, plus, now we figured out that sine theta is 3/8, so we're going to take this 3/8, remembering we have to square the whole thing, squared, that's equal to 1. So cosine squared theta is equal, plus 3 squared, which is 9, and 8 squared, 64. And how many 64ths do we have in 1? Well, we have 64 64ths. So now solving for cosine squared theta, if we subtract 9 64ths from both sides of this equation, okay, we're going to have cosine squared theta is equal to, what's 64 minus 9? I believe that's going to be 55. We have 55 64ths. So cosine theta, which is the square root of cosine squared theta, is going to be square root of 55 over square root of 64, which is 8. Now, we've got to ask ourselves about the plus or minus. Are we going to have plus or minus? Well, the thing's going to be plus. We know all ratios are positive, so this will be our value of a cosine, which is square root of 55 over 8. Next, we're going to find the tangent, and tangent theta is equal to sine theta over cosine theta. And so in this case, we have tangent theta is equal to, our sine is 3/8. And divide by cosine theta, which is going to be square root of 55 over 8. And then dividing by a fraction, the same as multiplying by its reciprocal, so we're going to be equal to 3/8 times 8 over square root of 55. And so we cancel 8 over 8. So tangent theta is going to be equal to 3 over square root of 55. And if we, to rationalize this value, if we multiply by square root of 55 over square root of 55, we're going to get 3 square root of 55, and multiplying the denominator by square root of 55, square root of 55 times square root of 55 is 55. So the book gives both of these values as correct answers. So that's going to be problem number 13. Now our last algebra problem in this set is problem 15. And we're going to examine where the sign of where this is located. Here we draw x-axis, y-axis. And secant theta is going to be related to the cosine. So cosine theta equals 1 over secant theta, which is going to be just the reciprocal of secant theta. So we're going to have negative 2 over 9. So cosine theta is actually less than 0. Where is cosine theta less than 0? Well, quadrants 2 and 3. Okay, so quadrants 2 and 3. And then we're given sine theta is greater than 0. So sine theta is greater than 0. Where? Well, that'd be quadrants 1 and 2. Okay, and quadrant 2 is the quadrant in common between these two conditions. So let's go ahead and work this out. Well, to find sine theta, we already figured out what cosine theta is, didn't we? So we can take our trigonometric Pythagorean identity, sine squared theta plus cosine squared theta is equal to 1. And we're going to try to find out what sine theta is. So sine theta is equal to, let me just write up the sine squared theta plus cosine squared theta. So we're going to take this negative 2/9 squared, and that's going to be equal to 1. So sine squared theta plus What's 2 squared? That's going to be 4 in the numerator. In the denominator, 9 squared is 81. And on the right side, how many 81s do we have in 1? Well, we have 81 81ths. Sounds weird, but it's the truth. Now, to solve for sine squared theta, if we subtract 4 81sts from both sides of this equation, 4 over 81, we'll have a cancellation of on the left side. So we're left with sine squared theta equals, what's 81 minus 4? We're going to have 77. And then taking the square root of both sides, we're going to have sine theta is equal to, we're going to have square root of 77 in the numerator. In the denominator, we'll have square root of 81, which is 9. And let's see, sine theta is greater than 0, so that's going to be a plus. So we don't have to add a negative sign there. We can just leave this answer as is. And then we're going to try to find, or we are going to find the cotangent next. And cotangent theta equals cosine theta over sine theta. So cotangent theta, and what is our cosine theta? That's going to be negative 2/9 over our sine theta, which is going to be square root of 77 over 9. And this is going to be equal to negative 2/9 times the reciprocal of this square root of 77 over 9. So it's going to be 9 over square root of 77. And 9 over 9 cancel each other. So our cotangent of theta is equal to negative 2 over square root of 77. And rationalizing, if we multiply this negative 2 over square root of 77, we're going to get negative 2 square root of 77 over square root of 77 times square root of 77, which is 77. So that's going to be our answer for our cotangent. And really, that should be it. I hope this has been helpful to you. Tried to assume that you didn't know everything going into this. Good luck with your even number problems, a demonstration for learning, and thanks for viewing.